Welcome to The Explainer, Class 7 students. Today, we're literally becoming weather detectives to uncover the fascinating mysteries of the atmosphere. I mean, we experience it every single day, right? But we rarely stop to think about the incredible science happening right above our heads. So get ready to sharpen those observation skills because we are diving right in. Listen to this beautiful thought from the French novelist Marcel Proust. Think about it for a second. Waking up to a sunny, crisp morning just makes you feel completely different than waking up to a dark, stormy sky, doesn't it? The weather doesn't just change the landscape outside. It totally changes how we feel inside, what we decide to do, and even what we end up wearing. It truly creates our world anew. So here's our mission map for today's Explainer. We're going to kick things off with a welcome to the troposphere, break down the 5 weather elements, decode nature's weather clues, check out some modern weather instruments, and finally, look at predicting the future. All right, let's jump straight into Section 1 and figure out exactly where all this weather actually happens. You know, our bodies act as the absolute ultimate first line of weather detection. Long before you check that app on your phone, your body is already sensing the environment. You wake up on a chilly winter morning, you shiver, and boom, you immediately reach for thick, heavy clothes. But in the summer, you're sweating, so you're choosing light fabrics to keep cool. We are constantly, automatically responding to the atmosphere. But what are we actually responding to? Well, weather isn't just some vague concept of hot or cold. It actually has a very precise scientific definition. It is the exact state of the Earth's atmosphere at a particular time and at a particular place. But to really get that, we kind of need to know what the atmosphere even is. Picture the atmosphere like a giant layered cake. It's this massive blanket of gases surrounding our planet stacked up in layers. Now, the very bottom layer, which extends just 6 to 18 kilometers from the ground, is called the troposphere. It's thinner at the cold poles and much thicker in the warm tropics. But here's the absolute game changer. This relatively thin bottom layer is where we live, where we breathe, and where literally almost all the weather phenomena you'll ever experience takes place. Moving right along to Section 2. Let's look at these specific ingredients that make up our weather. If weather is a soup, these are your 5 key ingredients. These core elements are constantly interacting in the troposphere. First, we have temperature, how hot or cold the air is. Then precipitation, which is any form of water falling from the sky, like rain or snow. Atmospheric pressure is the actual physical weight of the air pressing down on us. Wind is simply the movement and speed of that air. And finally, humidity, which is the amount of invisible water vapor just sort of hanging out in the air around us. But here's a pretty fascinating problem with just relying on our senses to measure these. Imagine Krishnan from Chennai is on the phone with his buddy Amir in Kashmir. Krishnan says, "Man, it rained last night. It's absolutely freezing here today." But if Krishnan actually shared the exact temperature, Amir would probably laugh and say, "No way, that's not cold at all. That's a beautifully warm day." Human senses are totally subjective. What feels freezing in a hot coastal city might feel like a perfect spring day up in the mountains. Let's move to Section 3 and discover how people read the weather way before we had modern technology. For thousands of years, humans relied completely on nature's signals. Before any gadgets existed, people closely observed animal and plant behavior to forecast incoming storms. They'd notice birds flying way lower to the ground before a storm hit. They saw ants frantically rushing to move their eggs to higher ground to save them from floods. Even plants get in on the action. Like pine cones will naturally close up tight in humid conditions to protect their seeds, and then pop open when the air is dry to release them. It's like nature has its own built-in weather stations. Now, in Section 4, we'll see how scientists created some incredible gadgets to actually measure all this stuff accurately. Keeping track of all this data requires some serious organization. Here in India, the India Meteorological Department, or the IMD, handles this massive task. And get this, they've been doing it since 1875. I absolutely love their official motto. It's drawn from ancient Sanskrit, Adyata Jayate Rijti, which beautifully translates to, "From the sun arises rain." It perfectly sums up how the sun's heat drives the whole water cycle. Today, they use automated weather stations, AWS for short, scattered all over the country to constantly gather data 24/7 without even needing a human there. So to avoid that funny confusion we talked about earlier between Krishnan and Amir, meteorologists use standard instruments. To measure temperature objectively, we use thermometers. Whether it's a classic liquid-filled one or a super precise digital one, they give us hard, undeniable numbers. And we use standard scales for this. So a cool 15 degrees Celsius is exactly equal to 59 degrees Fahrenheit, no matter where on Earth you happen to be. And once that data is collected by those thermometers, scientists track the maximum and minimum temperatures every 24 hours. This lets them calculate some really essential statistics. They can find the daily mean just by adding the max and min together and dividing by 2. Or they find the temperature range by subtracting the minimum from the maximum. Doing this day after day is exactly how we spot long-term climate patterns. Next up is precipitation. When a news reporter announces that a city just got 30 millimeters of rain, they aren't just making a wild guess. They know this thanks to a really clever instrument called a rain gauge. It's actually brilliantly simple. Rainwater falls into a funnel and collects inside a marked cylinder. If that water reaches a depth of 5 millimeters on the scale, well, that area officially received 5 millimeters of rain. Okay, now let's talk about atmospheric pressure. We measure this with a gadget called a barometer, and the units are called millibars. For context, normal sea level pressure is right around 1,013 millibars. But check out this number, 650 millibars. That is an incredibly low reading. It's actually the atmospheric pressure at Hardung La in Ladakh, which is over 5,600 meters above sea level. Because the air is just so thin up there and the pressure is so low, our army personnel actually need to pause their journeys just to let their bodies acclimatize to the extreme lack of oxygen. Rounding out our gadget tour, let's capture the invisible elements. We use wind vanes or windsocks to see exactly which direction the wind is blowing, while anemometers track the actual speed using these little spinning metal cups. And what about that sticky humidity? To measure the exact percentage of water vapor in the air, we rely on instruments called hygrometers. All right, section 5. Let's see how all this incredible data comes together to actually predict the future and keep us safe. You see, modern meteorology isn't just looking up at the clouds and making a lucky guess. By feeding all that AWS data into powerful computers, meteorologists systematically study how those 5 weather elements evolve. This gives us the power to forecast the future, and this is absolutely crucial. It's what lets farmers plan their crops, helps pilots navigate safe aviation routes, and allows us to issue life-saving early warnings for devastating floods, cyclones, and extreme heat waves. Okay, time for a quick pop quiz to test your new weather detective skills. Go ahead and pause the explainer right here. See if you can match each modern instrument to the correct weather element it measures. If you've been paying close attention to our journey so far, I guarantee you'll nail this in seconds. All right, now I want you to apply your knowledge to a real-world puzzle. Jyotsna is packing for a school trip to Mumbai. She checks the meteorological data, and it predicts 29 degrees Celsius with a massive 84% humidity. Think about how those two specific elements interact. It's warm for sure, but the air is also completely saturated with water vapor. What kind of fabrics should she pack in her suitcase to actually stay comfortable in that thick, heavy air? Cotton, wool, maybe synthetics? As you figure out the best advice for Jyotsna's suitcase, I want to leave you with this final thought. We started with Marcel Proust, noting that a change in weather creates our world anew. But ask yourself, how does knowing tomorrow's weather change the choices you make today? Whether it's farmers planning their harvests, pilots flying planes, or just you deciding whether to grab an umbrella on your way out the door, this incredible science empowers us to step out into that troposphere with confidence every single day. Thanks so much for joining me on this explainer. Stay curious and keep looking up.